Hi everyone, welcome back to new video. So in this series or in this complete tutorial, you're going to learn about the most important concept is big O notation. So in this tutorial, okay, we are going to spend a lot of time on big O. It's a huge topic when it comes to data structures and algorithm. So what is big O? BigO is a way of comparing two sets of code, and let's say code 1 and code 2 accomplish exactly the same thing. How do you compare one against the other? Code 1 might be more readable, that might be better. Code 2 might be more concise, the code might take up fewer lines, and if that's what you're measuring, then you would say that code 2 is better. BigO is a way of comparing code 1 and code 2 mathematically about how efficient they run. In a coding interview, you will absolutely be asked questions about BigO. So let's look at what BigO is. Let's say we have a stopwatch and we run code 1 and we start the stopwatch and it runs for 15 seconds and we reset the stopwatch, then we're gonna run code 2. So the code 2 runs a lot longer than 15 seconds. It may run for a full minute. Based on this, you would say that code 1 is better than code 2. You can measure it. This is called time complexity. The thing about time complexity that is interesting is that it's not measured in time. Because if you took the same code and run it on a computer that runs twice as fast, it would complete twice as fast. It doesn't make the code any better, it just means the computer is better. So it is measured in the number of operations that is that it takes to complete something. And we look at example of that as we go along in this entire tutorials or the series. In addition to time complexity, we measure space complexity. So let's say that code 1, while it runs very fast comparatively, let's say it takes up a lot of memory when it runs, and maybe code 2, even though that takes much longer to finish, maybe it takes up less memory. In preserving memory space is your most important priority, then you don't mind having extra time complexity. Maybe code 2 is better. So when you get into an interview, there's a good chance that you'll be asked question about time complexity. And then they'll say, hey, well, what if space complexity is our main priority? How do you approach it then? You have to understand both concepts and be able to address that in the job interview. You have to understand both concepts to be able to address that in the job interview, right? But for the most part of this class, will be dealing with time complexity, and that is our quick intro to big O.